demonstration of our capstone project, that is solar powered electric cycle using a BLDC motor. Our project aims to combine clean energy, advanced motor techniques, and efficient energy management system to create a more sustainable and a practical way of transportation.
Our system is consist of three components. One is BLDC motor, another is solar panel for renewable energy, and another is a battery to store our energy.
The energy generation process begins with the solar panel capturing the solar radiations and converting it into the electrical energy. To maximize the energy output, we use a boost converter which steps up the voltage to make the battery charge efficiently. Here we are talking about our boost converter. We are giving it an input of nearly 11-12 volts, and our boost converter is boosting the voltage to 36 volts, and we are getting a constant power output of 36 volts. Now if the voltage fluctuates and goes between the range to 18 volts or 17 volts, then also our boost converter successfully boosts it to a constant 36 volt, which is efficient for the charging of our battery. We have used two solar panels for our testing. First we used a small solar panel which was giving us the power output of nearly 16 volts. Then we connected our boost converter to that solar panel and took it outside in the sunlight, and after boosting the voltage we were getting a voltage of 36 volt, which was ideal for our battery, but we were getting a less power output from this. After this, we used our bigger one solar panel, which we have also mounted on our cycle. It was normally giving us an power voltage of 18-19 volt. After boosting it through our boost converter, we were getting an constant output voltage of nearly 36 volts, which was ideal for our battery.
The BLDC motor operates on three-phase system to achieve smooth and efficient motion. To control motor speed and torque, we use field-oriented control, that is FOC technique. This advanced vector control method generates sine wave to control the current flowing through the motor winding and for better performance. FOC uses mathematical transformations to convert the three phases AC motor current into rotating reference frame, that is DQ reference frame. This simplifies the control problem by breaking down the current into two orthogonal components. First one is direct axis current ID. This component controls the magnetic flux in the motor, and second one is quadrature axis current IQ. This component controls the torque in the motor. We have the three-phase current IU, IV, IW. Then we perform the Clark transformation on the IU, IV, IW, and we got I alpha and I beta. Then we perform Park transformation on that, and then we get ID and IQ respectively. Then this ID and IQ goes through the PI torque controller, and we get VD and VQ voltage. And then we perform inverse Park transformation on the VD and VQ, and we get V alpha and V beta respectively. Then we perform also inverse Clark transformation, and we get three-phase voltage.
Here we can see that our sine controller is giving motor a pure sinusoidal three-phase voltage. Here we are analyzing the any two phases of our three-phase voltage, and we are getting a good square wave and a perfect sinusoidal waveform. Here we can see a close-up view of the waveforms which we are getting from our sine wave controller. Now coming on to the current part, current which is flowing through the motor increases as load increases. See, as here you can see, first a normal less current is flowing, a normal AC current is flowing, but as load increases or terrain becomes difficult, the magnitude of the current flowing increases rapidly, and then it decreases when the terrain becomes normal. Here you can get a close view of our hub motor. This is our battery and we have mounted it on our cycle. The battery is giving power to the sine wave controller, which is connected directly to the battery. The sine wave controller then is connected to the motor. Then the sine wave controller is connected directly to the throttle. The throttle is the main key aspect which controls the current flowing to the motor. This project promotes sustainability by using clean energy. The solar panel not only powers the motor but also reduces its dependency on grid, which makes it ideal for both rural and urban areas. Thank you for watching. We hope our project inspires more sustainable engineering solutions.
And also feel free to contact us if you have any queries or any better ideas.
Together, we can build
We can build
a better future.